The paper introduces fine-tuning initial noise distribution, FIND, a novel framework optimizing the initial noise distribution of diffusion models. This approach enhances consistency between generated content and user input prompts by formulating the optimization as a one-step Markov decision process and employing policy gradients. A dynamic reward calibration module is introduced to predict the expected reward of the current initial distribution, guiding the optimization process. Additionally, a ratio clipping algorithm is proposed to reuse historical data and minimize the discrepancy between new and old policies. The framework is demonstrated to be effective and efficient in both text-to-image and text-to-video tasks, surpassing state-of-the-art methods in consistency and speed. The authors also discuss the fundamentals of diffusion models, including the latent diffusion model and the denoising process, highlighting the optimization objective to maximize the expected cumulative reward over trajectories. The paper concludes by emphasizing the importance of accurate reward values, proposing a dynamic reward calibration module to address this issue. The paper proposes a novel approach to optimize the initial noise distribution for diffusion models using policy optimization, specifically the ratio clipping algorithm, RCA. This method enhances optimization efficiency and generative performance, demonstrated through qualitative and quantitative experiments. The results show significant improvements in color accuracy, composition, and location in generated images, outperforming baseline and state-of-the-art approaches. Additionally, the method achieves a 13-fold reduction in computational cost. An ablation study highlights the importance of the DRCM component in preventing the network from optimizing in incorrect directions. The authors further explore the fine-tuning of the initial noise distribution with policy optimization, demonstrating its effectiveness in enhancing the quality and consistency of generated images and videos. The proposed method is evaluated through various experiments, including an ablation study and a user study. The ablation study reveals that removing the DRCM and RCA components leads to a decline in both image reward and aesthetic score metrics. The user study shows a significant preference for the proposed method in terms of appearance and alignment, with improved text-image consistency. The method is also nearly 13 times faster than the baseline. The paper extends this approach to video diffusion, showcasing its generalization through a case study on text-to-video diffusion models. The results indicate improved text-video consistency, interframe consistency, and predicted user preferences compared to the baseline. Overall, the research presents a significant advancement in the field of diffusion models, offering a more efficient and effective approach to generating high-quality images and videos. The paper introduces FIND, a novel framework for fine-tuning diffusion models with policy optimization. Unlike previous methods, FIND optimizes the initial noise distribution directly through the reward function using policy gradients, aligning generated content with user input prompts. The authors observed that the initial noise significantly influences the final output of diffusion models, leading them to optimize the initial noise directly through the reward function using policy gradients. They proposed the DRCM to predict the expected value of the reward under the current distribution and developed the RCA module to leverage past samples and ensure optimization stability. The authors demonstrated the effectiveness of their proposed method on various tasks, including text-to-image synthesis, image-to-image translation, and video generation. They showed that FIND can be applied to kinds of diffusion-based generative models, demonstrating its high generalizability and versatility. Extensive experiments and qualitative tests have proven the effectiveness of their proposed method. The paper also provides a comprehensive list of references, including recent works on diffusion models, text-to-image synthesis, and reinforcement learning. The authors also provide detailed derivations of their equations and additional examples of their method's capabilities on the drawbench dataset. Furthermore, they conducted an experiment on complex prompts to validate the effectiveness of their approach, demonstrating its ability to generate high-quality content while maintaining control. In the quantity evaluation, the authors employ the image reward and aesthetic score metrics to assess consistency and quality, respectively. They also report the total training time for the evaluation dataset. The results show that their method outperforms the baseline and DPOK in both metrics, while requiring less training time. The authors visualize the reward values sampled during the optimization process, observing an upward trend that slows down after 150 iterations. They set the number of optimization steps to 150, considering the time consumption. To validate the generalization performance of their method, the authors experiment with 3 custom models from the Civitai website, demonstrating the capability to optimize the initial distribution for different models and aligning generated images with prompts. The authors discuss the limitations of their method, noting that it treats diffusion models as a black box and is highly dependent on the baseline model's generative capability. They acknowledge that the method can only unlock the latent potential of large-scale pre-trained models and is limited by the reward function used. Future work involves experimenting with more baseline models, including Texto 3D and robot control, and using large language models as the reward model to achieve more precise control. The authors also provide sample images generated from draw bench prompts, showcasing the diversity and complexity of the generated images. The research paper presents a novel approach to fine-tuning initial noise distributions in diffusion models using policy optimization, dubbed FIND. This method enables the generation of high-quality images that match user-provided prompts. The authors demonstrate the effectiveness of FIND through various figures showcasing diverse styles, compositions, and themes, ranging from surrealistic to photorealistic. The results highlight the ability to capture complex prompts and exhibit high levels of realism. The author's approach leverages policy optimization to adapt the initial noise distribution, allowing the diffusion model to better capture the target prompt. This leads to images that are not only visually appealing but also semantically consistent with the input prompt. The paper contributes a novel fine-tuning strategy for diffusion models, demonstrating potential applications in computer vision, graphics, and artificial intelligence. Future work may involve exploring alternative generative models and fine-tuning strategies to further improve the quality and diversity of generated images.